Hey, Alex. You know how everyone's always talking about, quantum computing for super science stuff? Well, guess what? It's about to totally shake up education, too.
Whoa, really? Quantum computing? For schools? That sounds pretty futuristic. I mean, are we talking about teaching kids how to build quantum processors in elementary school?
No, no, not quite like that, Alex. It's actually way more fundamental. The idea is, instead of just training future quantum physicists, we're using quantum capabilities to build smarter, more inclusive, and just genuinely more efficient learning systems. It's about rethinking the whole ecosystem, you know? Not just better tools, but a totally different way of looking at knowledge and potential.
Okay, that's wild. So it's not just about a faster calculator then, it's like a whole new approach? How does it actually do that, practically speaking?
Exactly. Think about it this way. Quantum computers are super good at simulating really complex systems with tons of interacting variables. So in education, that means we could model how students learn, right? Mimic cognitive processes, or even understand how learning disabilities like autism, dyslexia, or ADHD impact learning acquisition and retention. It's mind-blowing.
Wow, so it could really help understand how different brains work rather than just a one-size-fits-all approach. That's huge. But what about personalized learning? Everyone talks about that, but it always seems to hit a wall with how much data you need.
Oh, Alex, that's where quantum really shines. Personalized learning is a priority, right? But it needs to process just massive amounts of data. Student behavior, progress, preferences, classical algorithms, they can only go so far. Quantum enhanced machine learning, it could adapt content in real time, offering hyper personalized instruction. Imagine a tutor that just instantly gets your pace, your struggles, and get this, it could also improve early warning systems. So we'd intervene before a student even gets lost, not after. It's super proactive.
That's amazing. Like preventing problems. What about all the important logistics? Can quantum help with scheduling and resource allocation?
Absolutely. Course scheduling, classroom assignments, teacher deployment, all those logistical nightmares in big educational systems, right? Those are like classic combinatorial optimization problems, and quantum computers are perfectly suited to solve them. A quantum algorithm could quickly figure out the absolute best way to allocate thousands of classes across a university, reducing conflicts and making everything more accessible. Total game changer for administrators.
Okay, so it sounds like quantum computing could totally revolutionize the day-to-day of education. But what about the bigger picture? Research, understanding how we learn fundamentally.
Oh, that's where it gets even more exciting. Quantum computing could supercharge pedagogical research. We're talking about cutting through massive data sets, doing rapid iterations in educational research, and just, more complex evaluations of teaching practices. And on a deeper, more speculative level, scientists are exploring links between human cognition and quantum information theory. It's could quantum models help us understand memory, decision making? It could lead to entirely new instructional design frameworks.
Wow, that's really mind expanding. But with all this powerful tech, I'm thinking about the downsides too, like access and equity. If it's so advanced, isn't there a risk of, widening the digital divide?
Totally, Alex. That's a huge concern. If only elite institutions or wealthy countries have access, the digital divide just becomes a quantum chasm. And there's a real danger of deepening cognitive inequities, especially for neurodiverse or underserved students. Plus, we've got to think about privacy, bias, surveillance, all those ethical complexities when dealing with student data. It's not just about the tech, it's about how we manage it responsibly?
It's clear there's a ton of potential, but also serious hurdles. What's the global outlook? Are countries actually taking this seriously right now?
Oh, absolutely, Alex. This isn't just a futuristic dream anymore. Nations like China, India, the UK, and all the EU members are making significant investments and creating formal policies to integrate quantum computing into their education systems. It's becoming a strategic national priority, for economic competitiveness and scientific leadership. We're seeing a huge rise in public-private partnerships, too, with educational institutions collaborating with industry leaders to develop hardware and new applications for quantum learning. It's like a global race to define quantum literacy across different educational levels.
So it's not just about building quantum computers, but building the people who can understand and use them. That's a massive shift.
Exactly. And this evolution means standardizing quantum-related skills and competencies is becoming super essential. It's about preparing learners for a future shaped by quantum possibilities, not just training a few experts. Global cooperation will intensify, but so will competition as countries try to secure their place in this emerging quantum landscape. It's a total strategic moment, like redefining how we prepare the next generation.